Adding vectors, it is a tough thing to do about vectors. We have to add one vector to another vector. And vectors are different from scalar quantities. In scalar, it is very simple. 10 plus 10, 20, or 10 minus 10 equals to 0. But in case of vectors, a vector of 10, another vector of 10 can produce any resultant from 0 to 20. They can produce a resultant of 1 or 2 or 3 or 4 or 10 or 11 or 12 or 13 or 14. Up to 20, they can produce any resultant. That is not the case with the scalar quantities. They are simply added or subtracted. So today in this lesson we will learn about vectors, how to add them, and you can see there is a portion on the left side of the screen is provided with some mathematical assistance over here, as we say. This is a triangle. It is not a right angle triangle, and it can be any, it is a general triangle. It can be any triangle, right angle or not right angle, with three vertices A, B and C, with three sides. A is A, this side is A, opposite to A, C is opposite to C, and small b is opposite to B. Small letters are representing lengths of the triangle, and capital letters are representing the amount of angle they are making with the sides. Now these are two rules that we are familiar with from IGCSE O levels, that sine A over A equals sine B over B equals sine C over C. We know this rule or this formula as a sine rule, and underneath there is a cos rule, that is a square equals to b square plus c square. That part is very similar to Pythagoras theorem, but there is a other part other than Pythagoras, because there is not a right angle triangle. It cannot be a Pythagorean theorem over here. Negative 2bc cos A, that makes the complete cos rule. Now, if we are finding side of A, we need to find all this and then find square root of the whole thing, because this is A square, not A. This is cos rule. Underneath, this is a right angle triangle. In a right angle triangle, it is very simple, that hypotenuse square equals to base square plus perpendicular square, and sine is opposite over hypotenuse and cos is base over hypotenuse. I should have added tan over here. I don't know why I didn't. Now, tan theta equals opposite over base. So this is the help that we need from mathematics in this topic. Now coming on the right side, what is meant by resultant of a vector? If there is a thing that has been done by three vectors, can we do the same thing with one vector only? That one vector that has the same effect as these three vectors have together is called the resultant of these vectors. There are many ways of finding resultant. One of them is that you are familiar with is the graphical method. In the graphical method, what we do is we arrange the vectors head to tail, or we arrange them in series. So where first vector ends, the second vector should begin from the tip of the first vector, and the third vector should begin from the tip of the second vector, and fourth vector should begin from the tip of the third vector, and so on till we arrange all the vectors. And while shifting a vector from one place to another place, what we have to be very careful about is the direction and the magnitude. We cannot change the direction of the vector. We can neither change its magnitude. So do not change the angle and do not change the size of the vector, and you can shift the vector from one place to another place. This will be resultant's x component and resultant's y component. As you can see, this is resultant's x component and this is resultant's y component. And resultant's x component will be simply the sum of 80 and 50 cos 30, and resultant's y component will be simply 50 sin 30. There is no other vector to contribute to the y component of the resultant. And by using this method, what we can do is, and again this is a calculation method, we do not need a very accurate diagram. It should be approximately right to make the right concept or right image in the person's mind. Other than that, we do not need the actual sizes or scaled size diagram over there. Now, all you need to do is use a calculator to find the resultant's x component, and then use calculator to find resultant's y component. And now what you have is, you have the x component of a vector and you have a y component of a vector which are perpendicular to one another, and you're looking for the resultant. And I think this is where the Pythagorean theorem comes very handy. Okay, so pause the video over here, do your calculation and see whether you get it right or wrong. And these are the answers I'm getting when I'm putting things in my calculator. So the resultant x component, which is 80 plus 25 cos 30, is 123.3, and the resultant's y component is 25. I use Pythagorean theorem to find out the resultant, which is exactly same as I calculated previously using the cos rule actually. And then if you have the vertical component and you have the horizontal component and you're looking for this angle, so you have opposite and base, and the relationship between these two is tan theta. So tan theta equals to 25 over 123.3. I use this over here to find out the angle that the resultant is making with the 80 Newton force. So I knew that the vertical component is 25, horizontal component is 123.3. Tan theta equals to this, and theta equals to tan inverse of this whole thing. And I again got the same answer I got earlier using the sine rule. So these are the two ways of adding vectors. Now you might be asking yourself, why do we need to learn two ways? Some of you might find the first method easy, the other will find the second method easy, but it is recommended to learn both of the methods. Why? The reason is, examiner in A levels does not always give a complete question where you have to find the resultant. It does sometimes, but that is a big question, and sometimes examiner does not have that many marks to offer for that question, and he has already or she has already given too many questions over there, and he has less numbers left. So what they do is, they solve the question to some steps, and then they ask the student to complete it with less number of marks. Now, it seems easy that some of the question is solved, but there is a difficult part of this, that we have to continue the method that the examiner has picked. We cannot change it. So this is where knowing multiple method becomes very handy, because there is no way that we already know the examiner will solve the question this way or that way. So what he does is, he already distributes the vectors into their components, and then he asks you to find the resultant. And then if you have already found the component, then this method is easier than using the cos rule or sine rule. When you will do more practice, you will realize this thing better. Thank you very much for now. Thanks for watching. This is one way to arrange the vectors. As you can see, this is A, and now vector B, instead of this space, I just joined B with the tip of A, and then C started from the end of B. Now they are connected head to tail. You can see the head to tail arrangement or the series arrangement. This is called head to tail arrangement. The vectors should be connected one after the other. So this is the job done by A, this is the job done by B, this is job done by C. If it is a displacement vector, so object A displaces the object, vector A, displaces the object from this point to this point. Vector B displaces the same object from here to here, and C takes that object from here and brings it over here. Can we do the same thing using only one vector? Yes, we can. As you can see on the diagram, this is the resultant. Why? Because it can do the job that A, B and C did together. So that's why we call it resultant, because it can do the same thing alone. This is another thing worth mentioning. Does order make any difference? Instead of connecting A, B, C, I connected C, B, A. And see on the diagram, you can see that B starts from the end of C and A starts from the end of B. And you see resultant is same. So that means this is the resultant, and this means that order does not matter, whether it is a plus b plus c or b plus c plus a or a plus b plus c. It makes no difference. So order is not important, and this is how we do addition of vector using scale diagram, or we say the graphical method of adding vectors. Not a recommended method for A-level exams. You know why? Because in exam you won't have that much time to draw vectors with angles and everything. You have to have a shortcut method in your sleeves. Now, there are many ways of adding vectors, as some of them are explained in this video. Stay tuned. Here's one of the method explained with an example. This is a 50 Newton force. This is an 80 Newton force acting at an angle of 30 degree. And we need to find the resultant. And I cannot draw a scale diagram as I did over here. This is a scale diagram, but in exams I cannot do that. So how can I find resultant using calculations? Listen, this angle is 30 degree. So I actually shifted this vector from here to here. You know why? Because to add vectors, they should be connected head to tail. So second vector, these two vectors are connected tail to tail. That is not the right way for vectors to be added. The second vector must start from the end of the first vector. So this is what I did. I shifted this vector from there to there without changing direction. This is a 30 degree angle, and you can see this is still the 30 degree angle. The size of the vector is same. So all I did is just cut this vector from here and pasted it over there. But you cannot do that in your exam. So see how will I solve this question. Now, if this is vector 1 and this is vector 2, this is where the object begins from, this is where it is ending. So this will be the resultant. Let me just clean some of the stuff that we don't need, and then we will proceed. So this is the element. This is the first vector, 80 Newton vector. This is 50 Newton vector. I did not change their sides or direction. And once you made this diagram, is it important for this vector to be exactly 80 or this vector to be exactly 50? And should the diagram be scaled? Actually, no. You know why? Because we are not doing it with the graphical method, and we are using calculations for this. So this is a time saver in the exam. This is how we proceed. Let me change a color for this one. This is 80, this is 50, and the angle that we need over here is, as we know, this is a straight line, 180. So this will be 180 minus 30, 150 degrees, and this is what we are looking for. Now, which formula comes to your mind with this? Let me go a bit up to show you the mathematical help. This is the formula that I want you to use or think of. This one. Because in this we can find the side that we need. And we only need angle opposite to it and the two other sides. Do we have that stuff over here? Yes, we do. We know this side, we know this side. We are looking for this one. And the angle opposite to the side is also given. So put everything in your calculator. Side that we are looking for, or I should not be using A for this one. I should use a resultant. It will be a square root of 80 square plus 50 square minus 2, 80, 50 cos 150. Now this is a tip from Mega Lecture for you guys. Instead of finding things in parts and writing them and then putting them again in the calculator, try to find out or try to set the whole thing in one way, the thing that you need on the one side and all other stuff on one side, and put all these things in your calculator in one go. Okay, so press the square root button and then press 80 square plus 50 square minus 2 into 80 into 50 into cos 150. Put everything in the calculator in one go. Do not use calculator several times. So what will happen is you might round off stuff, and every rounding off will take you away from the original answer. If you want your answers to be exactly same as the answers in the marking scheme, this is how you should be doing your calculation. Finding the relationship, putting the values in, and then doing the calculation in one go with no rounding off. Now, the answer for this one will be, so when I put everything in the calculator, I get 125.8 Newton as my answer, and that is the resultant force acting over here. This one is 125.8 newtons, or as the question used three significant figures, so you can also round off your answer to three significant figures. 126 newtons. So these two answers are equally good. You can use any one of them, but this is not where the question ends. We also have to find resultant angle of the resultant from one of the vectors. This can be this angle, or it can be this angle, any one of them. It depends on the question as well. Or if it is not mentioned in the question, you can find any of the angle and state that this is the angle from that force. Like for example, if you figure out or calculate this angle theta, you would say that this is angle theta from 80 Newton force, or this is the angle that resultant makes with the 80 Newton force. So this is how you will state the answer. But how will you calculate it? Let me take you back to the other part of the mathematical assistance I showed you earlier. This is your helper in this case. Sine A over A equals sine B over B equals sine C over C. So you can use any pair of known side and angle to use that to find out a missing side or missing angle. In this case, we have a missing angle. So I will use sine theta, that is what I have to find, and opposite side is 50, equals sine of 150 divided by 125.6, actually 0.8. So theta will be 50 divided by 125.8 multiplied by sine 50, 150 actually, sine inverse of everything. Okay, so again, my recommendation, you put everything in your calculator in one go and find out your answer. 11.46 degrees, and a proper answer for this one should be 11.5, because 11.46 is too many significant figures for an angle. So the answer should be 11.5 degrees. And you can always confirm or check calculations, because I do them in calculators that are not recommended for IGCSE or exam point of view. So you can check calculation. If they are wrong, you can mention them in the comments below, and we will see if we can fix them. Thank you very much. There is another way of adding the same two vectors that we added already. This one was 80.0 Newton, and this one was 50.0 Newton. So actually these are two forces, and this angle was 30 degree. So what we do is we split the 50 Newton force in two components. One along the 80 Newton force, and the other is perpendicular to 80 Newton force. And we do not need this one, so I will get rid of this and this one, because we have shifted it over there, so we do not need this vector anymore. I will be getting rid of that, and I will be splitting this angle, this vector, into its component as well. Now this is how we do it. This vector will be, this component will be 50 cos 30, and this one will be 50 sin 30. There are some differences in my diagram, but actually I am trying to make this angle to be perpendicular to the other. Now when you need this resultant,